All righty, let's start our big day. Wednesday, or Wednesday, as you can also say. January 30th, the second to last day in the never-ending month of January. National Croissant Day. What's that? It has felt very long, yeah. Okay, but at least it had my birthday in it. Whose birthday's today? I thought JoJo's. Whose birthday, JoJo?
Oh, no. It's my birth month.
Oh, birth month. When was your birthday, Dar? Did we miss it?
No, we said it.
Oh, that's right. Oh, that's right. Okay, good. I got it. Okay, cool. So here is your warm-up / practice quiz for tomorrow. And y'all have already done it. I know. This is one way to charge the Apple Pencil, and it's also how you can sync it, right? Yeah. All right. It is. Okay, so now it should be synced. Yeah, there it is. Okay, great. So, in honor of Croissant Day, I'll choose purple. Yeah, I don't know. Yeah, it's just random. Yeah. Okay, so here's what I'm expecting on the quiz tomorrow. It doesn't really matter the order in which you list them. Doesn't really matter. But in an effort to perhaps help you learn them as like second nature, you would probably want to develop a habit of listing them in the same sequence every time. And so what I would recommend is your SOHCAHTOA sequence down the left-hand side. So sine of theta is how we read that, equals cosine of theta, and then tangent of theta. Okay, you can do it like that. And we don't want it in terms of O, A, and H. You want to get really good at just memorizing them in terms of X, Y, and R. Sine is measuring essentially the height of the triangle, right, compared to the hypotenuse. So, easy way to remember that. Y and sine both have the I sound in it, right? Sine, Y, right? Y, sine, Y, sine, Y, sine. Can't even really tell which one I'm saying at some point, right? Sine, Y, sine. Okay? So it's Y over R. Cosine is measuring essentially the width of a triangle with respect to the hypotenuse. So it's X over R. So cosine and X. Cosine X. That doesn't really work. Okay? So just remember cosine is the width. And then tangent is Y over X. It's the vertical to the horizontal. Okay? So those are the three main ones. Now you can get in the habit of listing in the second column the reciprocals of these fellas. All right? The reciprocal of sine is what? Nope. Cosecant. As I said, every non-co name is paired with a co-name. Every single one of them. So if you think the reciprocal of sine is secant, you're like, ooh, sine and secant, there's no co in either one of those. So that would be incorrect. Okay, it's sine and cosecant. So that would be naturally R over Y. And then the reciprocal of cosine would be secant, which we abbreviate SEC, of theta, and that's R over X. And the reciprocal of tangent is cotangent, which we abbreviate cot, of theta, and it's X over Y. Okay? So memorize. Okay? Got to know this. Moving forward, if you don't know this, and I'm talking like really know it, like immediately, like if you see cotangent, you're thinking, ooh, X over Y. You don't have to actually sit down and figure it out. You're just, oh, X over Y. Okay? So that would be your quiz tomorrow. 300s pretty much, right? 300s. Right, good. All right, so let's move on then. Here are the 6 of them again. We listed them up here yesterday. But here they are in a box, right? And, of course, things that come in a box are always pretty nice, right? Whether it's a Christmas gift or a dozen donuts. Or, in this case, a half dozen trig functions, right? Cool. Because these functions can be defined by rotating any radius r, which we know is the hypotenuse of these reference triangles, through any independent angle theta in standard position, we call these fellas circular trigonometric functions. Okay? we're not going to actually use that word circular. We're just going to call them trig functions for short. Trig functions. Okay? What? I'm just scratching. Okay. Now, what? Okay. I am recording. Okay. What? I don't know. Ooh, yeah. Okay. What? Okay. Let's keep going. Let's look at example 3. Okay. I call the next set of questions, I call these 2 clues problems. There you go. It sounds like Blue's Clues, right? We all watched Blue's Clues. Blue's Clues. There you go. Y'all grew up watching Blue's Clues, right? And I grew up not watching Blue's Clues, but I watched it with my kids as they were growing up. And I still watch it every once in a while. Just because it is good. It is good. And then I found out that Blue was actually a girl, and I was like, what? What? Yeah. And then Steve, when he went off to college, quote unquote college, also known as drug rehab, it just never was the same. Okay? Yeah, anyway. So these are two clues problems, and much like watching an episode of Blue's Clues, we're going to solve a mystery, okay? And we may get to say the word periwinkle. In fact, I am going to use periwinkle as my color, okay? Periwinkle was the cat. And I don't know if it's a boy or a girl. And then magenta was the other dog that looked just like Blue, but it was a boy. Yeah, magenta was a boy, and that was...
Why did they choose magenta as the color?
I don't know.
You're teaching kids.
I don't know. Okay. Blue skidoo, we can too. He goes in. Right. Mail time. Here's the mail. It makes me want to... Okay, whatever. Mail. Sine, example 3. If sine of some angle theta is 5/6, and that angle theta lives between 90 degrees and 180 degrees, find the simplified exact value of the other 5 trig functions of theta, and then find the value of theta and theta ref using the calculator Medora. All right. So here's the two's clues, why we call it two's clues. Sorry. I need to figure out the quadrant in which theta lives. And I have 2 clues that are given to me, okay? The first clue is the sine ratio, okay? So if sine of some unknown angle theta is 5/6, what is the ratio for sine in terms of x, y, and r? Sine y. Well, good, y over r. Now here's something that's important. I'll say it right here, right now. Oh boy, r is always positive. He was the valedictorian of Rachel's Challenge School. Okay? He is always positive. Okay? It's a radius of rotation. We do have advisor today. Okay? So R is always positive. But X and Y can be positive or negative depending on the quadrants in which they live. Okay? So if you have a positive sine ratio, it is because Y is positive. See that? This is a positive ratio, and so we know that Y is also positive. Okay, so based upon that, let's go ahead and draw some coordinate planes, or just one, I guess, in which 2 quadrants is sine and Y positive. 1 and 2, okay? So the trig ratio alone puts me into 2 of 4 quadrants, okay? Sine is positive when Y is positive. Y is positive above the x-axis in either quadrants 1 or 2. So theta lives in either quadrants 1 or 2. Man, in order to narrow it down to a single quadrant, we need one more clue. Okay? Wake up, Jeff. That was the Wiggles, actually. Yeah, right? Fruit salad, yummy, yummy. Stop at the light, look both ways again. Wait for the traffic to pass you by, then cross the road with a friend. Okay. Henry the octopus is down in the deep blue sea. Here's the, sorry, yeah, I'm still doing it. Here is the second clue. It says that theta is between 90 and 180. Well, which quadrant is that? 2, right? Here's 90 degrees. Here's 180 degrees. So, man, I only needed that one clue. That one clue is all I really needed. But it's nice that I have a sine ratio. So, here's what we do now. We draw just a random terminal ray. And you can always draw it at the 45. I don't care. That kind of gives you the maximum amount of space to work with. And then label that as theta. Okay? Now, to get a reference triangle, we need to what? Drop a horizontal? No, we drop a perp, right? So drop a perp, pick any point, I don't care. Kind of go out there and drop a perp, and that creates a right triangle. Okay? Now, here's the cool thing. Remember I told you yesterday not to forget to remember what a trig function is. What is a trig function? It is a ratio of what? I'm just looking at what time we get out of here, 9:35. It is a ratio of 2 of the 3 sides of a right triangle. Good. So if sine is 5 over 6, and sine is also y over r, then y could be 5, and r could be 6. So let us label the side lengths. Positive 5, positive 6. Yeah? Yeah. Okay, good. R is always the hypotenuse. Always. Okay? Always. And it's always positive. Okay, now, I need to find the other side. Because if I can find the third side, which is x in this case, I'll know all 3 sides. And if you know all 3 sides, you essentially know all 6 trig ratios, right? It's just a matter of listing them. So what do we use? Pythagorean Theorem. So let's go ahead and do that. We got y squared, which is 5 squared, plus I'll just say x squared equals 6 squared, right? The P theorem. So I get x squared equals 36 minus 25. And that means x squared equals let's just go to x. Remember when we take the square root to consider what? Positive and negative. Now this is hugely important. This is where students in haste can make a careless mistake. Remember, r is always positive, but x could be positive or negative, depending on the quadrant we're in. In fact, you might think to yourself right away, we are in quadrant 2, where x is what? Negative. Okay. So it's going to be the square root of, what is that? 36 minus 25? 11. Does square root of 11 simplify? No. So now that we have plus or minus, let's go ahead and commit to the negative one. All right? So it's very important that you get into the correct quadrant, right? Because if you're in the incorrect quadrant, you're going to get probably the wrong sign, SIGN, of one of your side lengths, which means all of your trig ratios, except maybe 2, are going to be wrong, right? That's not good. What's that? Yeah, you see where we're located? It terminates in quadrant 2. So to get to this point, I have to go left and up. So in other words, this coordinate here is negative square root of 11, comma 5. Okay? Very important. Y is positive because we're up. All right. Now that we have all 3 sides, let's list them. Okay? So let's just go ahead and set it up. Sine of theta, cosine of theta, tangent of theta. Okay? So let's see what we get for sine of theta. Sine is y over r. If you want to put that first, to reinforce it, that's fine. but you don't really need to write y over r, but it's okay to have it there. It's going to be 5 over 6. Hey, that's what they gave me, and I got the same answer when I set it up. That's fine. So you didn't have to list that one again, but it's nice to have the whole set. Cosine now is going to be what? Yeah, let's do that. It's x over r, so it's going to be negative square root of 11 over 6. Now notice that negative is right now in front of the square root of 11, but that could just as easily be the square root of 11 over negative 6. Or it could just be written out front, right? But we know that that ratio is negative, not because the r is negative, but because the x is negative. Okay, and then what's tangent? It's y over x, which is 5 over negative square root of 11. Now, I do want you to simplify your radicals. Square root of 11 does not simplify. And I do want you to rationalize your denominators if you have a radical in it, okay? There's a reason for that when we get to the unit circle. So, if you ever have a radical in the denominator, get rid of it. We need to multiply then by the square root of 11 over the square root of 11. You don't have to bother multiplying by the negative. You just know the ratio is going to be negative. So you end up with negative 5 square root of 11. I'll just pull the negative up front. All over what? What's the square root of 11 times the square root of 11? Should just be 11, right? It's square root of 11 squared. So by design, I mean, if you want to, you could say it's the square root of 121, which is, of course, 11. And there's your answer, negative 5 square root of 11 over 11. Isn't that a beautiful number? Yeah. All right, so now we got those three. So now it's time to list the other three. So the reciprocal of sine is cosecant of theta. Now, if you are 100% confident that this ratio is correct, you don't even have to look back at the triangle. You could flip it. But I wouldn't recommend that. I would recommend getting your information off the triangle and then comparing it to its reciprocal and see if it is, in fact, the reciprocal of it. All right, so cosecant is r over y. I'm not going to write down the definition. It's r over y, which is 6 over 5. 6 over 5. And heck yeah, that's the reciprocal of sine. All right, the reciprocal of cosine is secant. And so that's r over x. That's going to be 6 over negative square root of 11, which is, in fact, the negative square root of 11 6 flipped. But because we now have a radical in the denominator, what must we do? Multiply by a clever form of 1. And if you could do this in your head, after a little bit of practice, you could do this in your head. And I don't really need you to show the process of multiplying by a clever form of 1. You get negative 6 square root of 11 all over 11. Notice I pulled the negative out front again. And then finally, the last guy is Chuck of theta, right? Chad of theta. No, cotangent of theta, which is x over y. So that's the negative square root of 11 over 5. Negative square root of 11 over 5. Now notice, if you were going to flip tangent to get cotangent, you don't want to flip that version that you've already rationalized, because then you'll have to re-rationalize. You probably want to just flip that version before you rationalized it, okay? And there they are. There are all 6 trig functions, equations of that particular angle theta. We did that without a calculator, okay? Now, it is time for a calculator. So if you want to reach under your desk or wherever you keep your calculator, rolled up in your sleeve maybe. All right, so here is the first time we get to use our calculator with the trig buttons, okay? So, a little bit of etiquette. First of all, notice your calculator has a sine, a cosine, and a tangent button on it. See that? It doesn't have the other three. It doesn't have a cosecant, it doesn't have a secant, and it doesn't have a cotangent because it's not needed. Notice the second feature has sine to the negative first, cosine to the negative first, tangent. Thank you. That is not the reciprocal. I repeat, that is not the reciprocal. That is the inverse. Just like if you look on the natural log, you got natural log and e to the x. Those are inverses. Log base 10 and 10 to the x, those are inverses. Okay? So every key is matched up with its inverse. So if you want the reciprocal of sine, you have to go 1 over sine. You can't do second sine, all right? So here's what we're going to do. We want to figure out what theta is. So let's come down to our 6 trig functions. Now, because our calculator does not have cosecant, secant, and cotangent, I would stay away from that column. But notice we have now 3 equations that we could solve for theta. All right? Which one should we probably use of the sine, cosine, and tangent ratio? The sine, right? There's a couple of reasons. First of all, the sine one doesn't have a negative. That's a plus. Yeah. It also doesn't have a radical, right? So that's pretty rad. Yeah, it's getting worse. Notice that the cosine and tangent ones we calculated, right? We came up with those, whereas the sine one was what? It was given as a gift, so we know that's correct. So all roads in this case point to sine. The signs are pointing towards sine. All right. What? You could, and I'll do that afterwards. Okay, so let's go ahead and write sine of theta equals 5 over 6. Okay? How do you think we're going to get theta by itself? Are we going to divide both sides by sin? Is that how it works? No! That's kind of funny, though. That'd be a good script for like a Hollywood comedy. Not really. Do we multiply by something? Well, if I had like e to the 4x equals 1, how do I solve for x? What do I do to both sides? I take the natural log of both sides, because natural log is the inverse of e, right? Same thing if we had natural log of 4x equals something and I want to solve for x, I'll e both sides, right? Because e is the inverse of an ln of x. Same thing here. If you want to undo sine, you have to take the inverse sine of both sides. So right now that looks like this. That is the inverse sine. That's how we read that. Inverse sine. So you take it of both sides. You're not multiplying both sides by inverse sine. You're taking inverse sine. So you get inverse sine of sine of theta equals inverse sine of 5, 6. Okay? Now, what do you think happens on the left when you compose 2 inverse functions back to back? They undo each other, right? Start with theta, take the sine of it, which takes you over here. Then take the inverse sine, which undoes the work. It gets you right back to theta. Okay? They undo each other. So this is what we have. And that's what I want to see, okay? So you don't have to show that middle step. You could go straight from this step to that step. But I do want to see the equation you're solving. So now we have something to type into the calculator. Something else to consider, though. Are we in degrees or radians here for theta? Are we? Yeah. I mean, we're going to eventually work with radians exclusively, but because we're starting something new, it's always easier to start with degrees because we kind of understand degrees a little better. So those are in degrees. So your calculator has different modes. So here's kind of a bottom line rule. Anytime, for whatever reason, if you're doing a calculation on your calculator and you're going to be typing either the sine, the cosine, or the tangent button, at any time, if you're going to hit one of those 3 buttons, you better check yourself before you wreck yourself, okay? Which means go to your mode here, mode, and if you look down 1, 2, 3 on the 4th row, you have the option of being in radians or degrees, okay? Your calculator by default is going to be in radians, by default. So check it. We want to be in degrees, so let's float on down here. Click over to degrees and hit enter, and now it's highlighted, and you're like, oh yeah, I'm in degrees. If you do the problems in radians, you're going to be R-O-N-G wrong. Okay? Is everybody in degree mode? Mode, degrees, good. Okay, so second mode gets you quit. Now we're back on the home screen, and now we are ready to type in our inverse sine of 5, 6. So to get inverse sine, you hit the second command feature, second sine. Boom, there it is. And now you type in 5 divided by 6. And you could do it with the diagonal, and you hit enter, and it should give you an angle in degrees. 56.442. Yeah, I don't know. What angle is that? Very astute observation. Very good. If you come back over here, it told me the angle is 56.442. What do we know about our angle? It's in quadrant 2, so it's got to be between 90 and 180. Your calculator will always give you a right answer. The sine of that angle, 56 point whatever, is 5/6. I'll prove it to you, I promise, okay? Let's go ahead and store this just for kicks and giggles. Stow as alpha A. I'm just going to store it as A. We need to get used to storing things. Go ahead and take the sine of that. Hit sine, not inverse sine, of alpha A. And you're going to get this, which when you hit math, enter, enter, puts you back at 5/6. So the sine of that angle is 5/6. But it's not the angle we want. What was the other quadrant we said in which sine was positive? Which other quadrant did we highlight? Quadrant 1. Guess where 56 lives? In quadrant 1. Yeah. So your calculator doesn't know which quadrant you want to be in. So it gives you this angle here. I'll call it alpha equals 56 point whatever. Well, guess what? If you were to drop a perp from there and you label the two given sides 5 and 6, what do you know about those two triangles? They're the same. They're not only similar, they are congruent. They're exactly the same. Why is that significant? JoJo was already on it. That means that this angle here and this angle here are also the same. Okay? So you have to interpret the answer the calculator gives you. It gave you 56 point something, which is not only the angle, the other angle whose sine is 5/6, but as JoJo already said, it is also the what angle? Because it's positive and acute. It's the reference angle. Hot diggity dog. So let's write that down. The reference angle, theta ref. The calculator will always give you a correct answer. You have to interpret where it lives, and you need to find the reference angle. Well, we found it. It was 56.442. I'm going to truncate. All right, 56.442. Once you have your reference angle in your possession, by finding it from the calculator's answer, now all you have to do is look at your picture, use the reference angle to find your theta. Okay? If this angle here is 56, that means I'm stopping that much short of 180. So how do I find my angle theta? 180 minus the reference angle. Yes? So you'll always be able to find the reference angle from the calculator's answer. Your calculator is only going to give you one answer. And I guarantee the way I write questions, it's not going to be the one you want. Okay? You're going to have to work to find it. So here it is. This is why these problems are so much fun. They're delightful. I love them. Here we go. 180 degrees minus, we stored the angle in A, so minus alpha A. No rounding error. Hit enter. Ba-boom! It's 123.557 degrees. Okay? Is that a quadrant 2 angle? Yeah. Now, let's do something else. Let's store that one as alpha B. Okay? Alpha B. What did we say the sine of this angle was? 5/6. Let's try it. Sine of alpha B. That angle that we just found. If it's not 0.833333333, we're done for the year. I'm not teaching y'all anymore because it's not worth it. Math is not going to make sense, and I don't know why we're doing this. Okay? If it's not 0.83333, sleep in, come to second period. I'll count everybody present the rest of the year. Got it? All right. Let's hit enter. Yeah, boy, you still get to come to class. Oh, yeah, and learn this wonderful thing we call mathematics. Okay? Math, enter. 5/6. There you go. Okay? So that's why this problem is so delightfully fun, as I already mentioned. the trig function that you're going to be given, the one ratio, is always going to put you in two quadrants. The calculator answer is probably going to give you the quadrant, the other one, that you don't want to be in. And so you're going to have to find the reference angle from that answer. And then once you have your reference angle, you can find the actual angle by looking at your picture. Okay? Now, we actually are not going to get to the unit circle today. Darn it, I know. All good things must wait. We'll do it tomorrow, though. So someone else asked, was it Stacy? Yeah. Can we use another ratio? And the answer is, heck yeah. Was it you, Stacy? I don't know. Okay. All right, so let's go ahead and try using the cosine ratio. Okay, so here's all you have to show me. Theta would equal inverse cosine of negative square root of 11 over 6. That's what you would show me, okay? Let's go to the calculator. Second cosine of negative square root of 11. Now you got to click to the right to get out of the radical. Divided by 6. Oh man, I wonder what it's going to give me. Well, before we do that, let's think. I'm telling the calculator to give me an angle where cosine is negative. In which two quadrants is cosine negative? Good. Cosine is x over r. R is always positive. So if cosine is negative, it's because x is negative. This is why you really need to know the definitions. Okay? So it's going to give me an angle, the calculator, that's either in quadrant 2 or quadrant 3. Which quadrant do we want to be in? Quadrant 2. Okay? So let's see. Will the calculator give me a quadrant 2 or a quadrant 3 angle? Hey! That's the one we wanted. Man, we should just use cosine all the time because it always gives us the answer we want. Right? No, that's not true. That is not true. It is just true in this particular case. Okay, so we get 123 point whatever, I already forgot what it was. 557, thanks. Okay? No, it won't always give you the angle you want, but in this case it certainly does. Okay? What if I wanted to figure out, while we're at it, what if I wanted to figure out the other angle over here in quadrant 3 that had the exact same cosine? These two triangles would be congruent. How could I figure out that other angle? Well, oh yeah, you do. Can I find the reference angle from the 123 now? From your calculator's answer, you should always be able to find the reference angle. And the answer is yes. The calculator gave me 123. So to find the reference angle, that's not the calculator. I'm going to go 180 minus the answer. Okay? And now I find the reference angle. My calculator just froze. How beautiful is that? Guess what it's going to give me? 56.442. Now that I have that reference angle, guess all I need to do to figure out this, because now this angle is also the same, is now go 180 plus that reference angle amount. See that? And that's going to give me a different angle other than 123, but it's going to have the exact same cosine ratio. Let's see if it works. Okay, there it is. It's 56. So if I then add 180 back to that, boom, I get 236. What is cosine of that answer? Let's see. Cosine of that answer is that. And what is cosine of our angle, which we stored as alpha b? Should it be the same? Yeah, buddy. All right. We're going to stop there for today. But you see what we're doing? We are having loads of fun. We are drawing pictures. We are using the calculator to find an angle from which we can find a reference angle. Once we have that reference angle, we can then use our picture to work off the x-axis to find the angle that we want. Tomorrow we're having that short quiz like the warm-up, so be ready to rock and be ready to roll.